Hello guys, so in this video we will discuss about databases and in databases we will discuss about relational and non-relational databases. So in what is relational databases? Basically it consists of tables, many tables, and at each table we have rows which are horizontal, and we have vertical things which is called as columns. We might have seen the CSV format, .csv format file, which we can see in Excel. And when we open that, we see that there are tabular format data, and each cell has some value in it. Could be numeric, it could be some string format data in each of the cell. But in horizontal, if we see the horizontal, the series of those cells are known as rows, and in columns we know that it is a vertical series of the cells. So I think it is we already know what is CSV format and what is the table. But in relational tables we have multiple tables, so it can have 10 tables or 20 tables like that, depending on your requirement. Then, before creating any database, we need to define the schema, which is the logical design of the database. So, for defining the schema, we need to define what should be the name of the columns in each of the tables we have. So, say we have 10 tables, and each table have maybe 50 to 100 columns. We need to define each column names in each of the tables. We need to define the data types, whether it is numeric, whether it is date time variable, whether it is a string data, what kind of data format it is. We need to define the data type depending on the database which we are using. And so basically, this is a logical design, and we need to plan it before we create the database. We can also change it, but it's good to decide it before you create a database, so that there is nothing wrong happens in future. Now let us see what are the examples of relational database. The examples of relational database is MySQL, Oracle, Postgres, and SQLite. These are some of the examples of the databases which we have. So if you create some MySQL database, it will have multiple tables. Each table will have its own name, and inside each table you will have multiple rows and multiple columns. So each of the columns will have its own name again. Table, you can consider it as some kind of tabular format, .csv format kind of data. Now, MySQL, if you talk about MySQL, it is an open source. First of all, it is free. It has some positive negatives. Each of the database has its own positive and negatives. In MySQL, you can have null values. You can have missing values where you have dot any kind of thing. But MySQL does not support data partitioning and XML. We know about the data partitioning. When we are partitioning the data in the database, we do it using some kind of ID. And what does it do? It helps in making the query faster in the database tables. Okay. Now, if you are coming to Oracle, it is not an open source and not a free software. It does not support null values, and data partitioning and XML support is available in it. So this is a positive point in Oracle. Basically, Oracle will be used for large data sets. When we have a large data enterprise kind of data we have, then we need Oracle kind of thing. Now let us move to non-relational database. The basic difference between a relational and a non-relational database is that it is not a tabular format. Relational was a tabular format data, right? Now, coming to non-relational, it is not a tabular format, and we do not have a well-defined schema. Whereas in the relational database, we did have a well-defined schema. There we have multiple tables in the database, in one database. Here we have a table and it is called as a collection. A row is here known as document, is one observation, um, and column is kind of called as field, which columns we are talking of, right? Basically, non-relational databases will be used for some kind of text data, audio, video, mostly some of the data which is coming from social media kind of data, which is in the format of text, audio, video kind of data, right? So sometimes we do use relational and non-relational in combinations, and if you have a very specific use case where you have only text, you might be using only one type of non-relational database. And but when we talk of a enterprise level data, there you might have different kinds of databases working together in the whole system design. I will talk about all those in the future videos, how to design a complete system for maybe uh, e-commerce or traveling website or anything like that. So in that, for that purpose, you must be knowing which database is important and how these are being connected. Different services are talking to each other, and which database is kept in which service. Okay, now let us see some of the examples. So here we will talk about types of non-relational databases. So basically, broadly, if you categorize non-relational databases, there are many more, but these are the most broadly classified. Key value, document based and graph based, wide column based. When you talk of key value based, here you have key is some ID linked to the value we want to store. Value will be something which is the information which we need for a corresponding ID. For this, we databases are like Redis or Dynamo. There are other also. Redis is also used when you want to cache the data to make the make the communication faster in the network in the data flow. Now, now coming to the document based. It is stores data similar to the JSON objects. Okay, and it is MongoDB's. Its example is MongoDB. It is mostly used in kind of network data, like IoT data or something like that. Now you have graph based data. They store data in nodes and edges. It has some application in telecommunications. Uh, Neo4j is the database which we can use here. Wide column based dynamic columns, and by dynamic columns means you can change the columns number here. HBase, Cassandra are one of the examples. Now coming to MongoDB, where the MongoDB can be used is the example of MongoDB. Then an IoT platform requires support for data from many devices. Okay, so as I said that the company which is based on IoT, Internet of Things, the smart things which are being connected together. It's a network of smart things which are connected. It could be a home, it could be a office, or it could be anything. Wherever we have this kind of data, this data can be stored in a database similar to similar to MongoDB, and it handles data from different types of devices. And the database and the data structure is JSON based document database. It pulls the data using single index or multiple index such as device ID with location ID. records for a particular device in different locations are easily accessed. Okay, so whenever you have a use case similar to, like, you want to find the records for a particular device in some in different locations for a particular device, you want to find all the records in different locations, you can easily access using MongoDB. If you use any other database, you might be able to store the data which you have in IoT, but it could be very difficult to fetch the data, or also it would be very difficult to store the data in that format. Okay, basically, we would prefer a MongoDB because it is using a JSON based document database. Okay, now let us coming to Neo4j. When you will be using this kind of database, one example could be wherever you have a videos on maybe you can consider as a educational video tutorial portal. The data which you collect, get it from these kind of websites or portals, that can be stored in a Neo4j. And what is the positive point in this Neo4j is that whenever it is serving to the clients or to the users the videos which the website has, so the users can move from one lesson to the another, because say there is one chapter, it has 10 lessons, so user can move from one lesson to the other very easily if you have Neo4j database in the backend. Okay. Now we talk about Elasticsearch and PostgreSQL. Again, it is a non-relational database. Basically, these are kind of search engines, and it allows the users to search for menu items in restaurants. This is one of the example. So whenever you see a website which is allowing the users to search for menu items, different items, food items, on different restaurants who are delivering the food items, then we can use Elasticsearch in the backend for storing the data for the food items we have, and the restaurants and their each of the food catalogs they have. Uh, what happens is user is searching for something in the website of that, uh, and a user is putting some text on the search bar in the website of what it will be delivering is will be delivering all the results in the recommended format. So it will do recommend based on the text search. The thing is, why the Elasticsearch? Because when you are putting the text in the search, it will be delivering the result to the user in no seconds. So it is very fast. If you're using some other database, it will take some time to deliver it to the user, because user is sitting at some end, and the database is in some other place, and it is far. It is communicating through wireless communication. So what happens is, when the user is sending its query on the database of Elasticsearch, it will be responding with the results, recommended results, very easily in no time. Okay, now we will talk about the asset properties of DBMS, database management system. Basically, before talking of asset properties of DBMS, we will first talk of what is a transaction. Basically, transaction is a group of operations, and operations could be any read and write for different variables. And say, so A stands for atomicity, C for consistency, I for isolation, and D for durability. So what do you mean by atomicity? Okay, by atomicity it means that whenever there is a transaction, some maybe some variable is read, some other variable is read, some transaction is happening, either it will get completed or it will not complete at all. So it won't be like that it happens and it stops in the middle. So it is either completed or not completed. It is like that. So A is for that. C for consistency. So whenever the transaction is happening before and after, the net value remains the same. So it won't be changing. If it is changing, that means our database has become inconsistent. There is something wrong happened. Maybe something is, someone is reading the data before it is being written. So we need to make sure the database is such that it remains consistent at all the times. What is isolation? Isolation is when we have different transactions which are happening in parallel. They will happen in parallel without any interference. Without any interference. Okay. That should also happen as a property in DBMS. Now, D is for durability. What does it mean? After some transaction is successful, all the changes which has happened in that transaction which will remain saved. Okay. Now, these asset properties of DBMS is not present in all the databases. Some databases do have asset properties, some do not have. So we need to make sure that what kind of data we have. If it is kind of mostly in the real time data and in the monetary transactions, it is very important that we should have an asset properties to be fulfilled. Otherwise, there will be something wrong happen in the database, and whatever the analysis you do will not be good either in the present or in the future. Now we will talk of the CAP theorem. It is a consistency, availability, and partition. Now the asset properties which we discussed earlier, it was for the transactions. So focus point is whenever we are talking of asset properties, please remember that we are talking of the transactions. So for each of the atomicity, consistency, isolation, durability, it is we are talking of transaction. And transaction is actually a group of operations, and where operations means a read and write for different variables. Now, whenever we are talking of the CAP theorem, we need to make sure that we are not talking of the transactions here. We are talking of the servers or cluster we have, which are storing the data. So consistency, what does it mean? Consistency of what? Consistency of data remains the same among the machines. So for to make that consistency, what we do, any data write on the master or the primary machine should also instantly be replicated on the slave or the secondary machine before the write is declared successful. So if we have a cluster, in the cluster we have multiple machines. Say we have two machines, one is master, one is slave, one is primary, one is secondary. Either you say master or primary, it is same thing, slave or secondary, it is same thing. So we need to make sure whenever we are writing on the master, that should also be replicated instantaneously on the slave also before the write is declared successful. Otherwise, the data is not consistent among the machines. And if the data is not consistent among the machines, there might be some read is happening from some machine where the data is not consistent from the other machine, then there will be an issue. So we should always make it consistent across the machines. Availability, data is available to all the clients machine all the time. That means whenever the client is communicating to the database, uh, and the data is in the servers, right? So all the cluster, whatever we have, the cluster should be available 24/7, and it shouldn't be down. So it is not like that one of the machine goes down that and there is some breakdown and it is not available. And if the user is querying for something and he's not getting any response from the website, that means it is not available. There is some issues with the server or cluster. So that is again availability of the cluster or server. Now, partition tolerance, cluster must continue to work despite any communications breakdown. So again, it is a similar kind of thing. In the CAP theorem, we are always talking about the cluster or server. Whatever the machines we have in the cluster, that should be kept in such a way that whenever there is a read from the client side, there shouldn't be any issues. Also, there should be a consistency across of the data across all the machines, and there should be a partition tolerance as well. That means the cluster must continue to work despite any communications breakdown between any of the machines. So whenever we talk of asset properties, be careful that we are talking of the transactions, because here also we have consistency, and in the gap theorem also we have consistency. But here in the gap theorem we are talking of the servers or the machines, clusters, but in the asset properties we are talking of the transactions. In the next video I will try to create more videos on something related to databases in more detail. Thanks for watching this video.